Okay, now we are into the Origin software. This is one of the best data visualization software that I can recommend for creating high quality graphs or high quality visualizations of the CFD data. Now, what am I doing over here? The task what I'm doing over here is extracting the values of experimental data. I actually thought to not discuss about this thing, but I directly wanted to extract the values and create the graph and show you the results. But you might be wondering as to how did I get the values of experimental data from the existing image what I have. So I've splitted the image into three: x is equal to 0.2, x is equal to 0.4, and x is equal to 0.6. And one by one I'm importing them in this software and extracting the values in this fashion. Now this might be looking a bit confusing for you because you might not be aware of this software, and but still I just wanted to show you the best procedure to extract the values from reference images. On a general note, we cannot extract the values manually. I mean, it is impossible to extract the values manually. Sorry, I didn't adjust the axis for this. So we just have to import the image, and after that we need to select the points, and you will be getting the data with respect to the points what you have selected in this fashion. So you can see this is the x and y points of the experimental data, which I will be saving in separate workbook over here. Now if you're really interested to gain more information about the software, I already have a separate detailed course on this. If you're really interested, you can just check that out. But it is a best software in comparison with Microsoft Excel. That is what is my view in terms of representation of data. You can see how I'm utilizing this software for comparison of experimental and our CFD results. So you'll be understanding how we can create a very decent good looking graph in the presentation, especially if you're interested to present your results in the best possible way. Then I would really recommend this software to be utilized rather than utilizing simple spreadsheets of conventional softwares. And I just thought to directly show you the comparison results, but then you might be confused as to how I have extracted the value. So that is the reason I'm just showing you this method as well. And if you want, you can just skip off and move forward. But if you're interested, you can just see what we are doing to extract the values. So we just have to import the image, set the axis, then select the points for the respected locations, add the respected locations by double clicking at that point. So you can see I'm just hovering my cursor at the desired position and picking the points. There might be a bit left and right, like it can be having a bit minor variations, but that is well and good. That is not a big problem. And after that I'll get the data over here. I'll just copy this data and save this data in another worksheet in this way. So I'll just close this one, and I'll hide this image also. I'll better hide it, close it. So we have this data for experimental conditions. So we have obtained this data, and now what we can do is we can just go to the respected Excel sheets what we have exported from the CFD post. Okay, so this is for x is equal to 0.2, and I'll just copy this for x equal to 0.2, and I'll just recreate one more worksheet, book 2 over here, paste it over here. So this is CFD x 0.2. okay, so that we will be having a distinguish difference between both of these. Okay, now I'll need one more sheet over here so that I can open the x equal to 0.4, copy and paste over here. Will be x 0.4, add one more, open the x 0.6 velocity, and then just copy from there and paste over here. This will be x 0.6. Fine, everything is good. Now let us just create. Firstly, we will start creating the x equal to 0.2. I'll just go to plot, create a line plus symbol chart. Okay, and firstly what I'll do, I'll just edit this properties. So you might not be catching with my speed for this, but there is another option. I cannot go very slow and explain you all the options because that is a separate course in detail. I cannot waste the time because this course is oriented for CFD. I just want the width to be reduced as 30, and also the scale of this X chart or X axis. So I'll just make it as okay, and we can just box this one, increase this one, and also make it 0. Okay, so that it starts from 0, and click OK. So this is what this stands for, X point 2. I'll write CFD over here, CFD. And now for this one, we can just reduce the size a bit more, the width. Okay, and if you want, you can just write u velocity, and you can write units as well. I'm just ignoring, and this is y or z, that is the height. And this one is experimental data. I'll just select this and dump over here. And for experimental data, we are only required to show the symbols, so we can just select it, scatter, and change the color of the, so you can see the experimental and the CFD are coinciding, right? So this is a very good point over here. And if you want, you can just bold these as well. Okay, and just bring this box over. So this is for x is equal to 0.2. Clear? You can clearly see the comparison of experimental and numerical results. If you want, you can just change the symbols for symbol style for this one to unfilled, so that the blue color are more clearly visible, right? And this is experimental. I'll just write expt, and we will reduce the size of this one to 14. And bold this one. Clear? So x is equal to 0.2 is given as appropriate results. Done. Now x is equal to 0.4. I'll just select this one, go to plot, line plus symbol, and firstly I'll just reduce the width of this to 28. Applied. Now I'll add a frame, increase the thickness of the frame, change the scale over here to 0.04, click apply, then go to vertical axis and make this 0. Things are looking fine. I'll just change this one to u well, and this to y, so that it is, you can also write the units. I'm just ignoring as of now, so don't get confused with that. Change the symbol if you really want it to be more interesting. And this is CFD, the one what we have simulated so far. And let me bring in the x equal to 0.4, and the experimental data must be represented using scatter. Okay, and let me change the color to blue. Apply. So you can see for x equal to 0.2 as well, there is a very clear what do you call, a very good comparison. I mean, the results are extremely closer, and they are getting satisfied. So we can say with this comparison that the setup what we have used is pretty good, and it is satisfied with the use over here. Fine. So x equal to 0.4 is done, and you can see a good comparison of results. Only at this region there are some difference, but that is again very less, so that is fine. And we will just go for x equal to 0.6. So I'll select this one, and we'll reduce the width of this one to 28. Right. And if you desire, you can change the scale for this one, that is the vertical one, to 0. For the x1, I'm increased the scale and add the frame thickness, really like it to be 3. Then make it as CFD. Now go to x equal to 0.6 experimental data, drag it and dump it over here. For this one, it should be scatter and blue color. Click apply. For the first one, I am maintaining it as without symbol. Okay, click apply, and probably you must increase the scale a bit because this is just moving a bit right side. So the horizontal, we can just keep it at 95. Right, this is well and good. And bring this inside. You can just select and reduce the scale. And this blue color one is experimental. And if you want, you can just change UL, that is U velocity, and this will be Y here. And you can see the comparison of three charts. Just open all of these three. Okay, so in the three cases, what you're finding over here is a clear comparison of experimental and numerical results for three positions, that is x equal to 0.2, x equal to 0.4, and x equal to 0.6. I didn't write over here, but that is understood as we have seen the procedures. We have comparison of creating the graphs. Now with this method or with this comparison, you can prove that the what do you call the CFD setup what we have considered is, I mean, you can see for x equal to 0.4 there is a difference for them also, the simulation what they have done and what experiment they have done. So for us also there is a minor difference over here. So that indicates the appropriateness of the setup of the strategy what we have followed for the complete modeling of the indoor environment. I believe we have understood really well how to tackle the indoor environment flows, and I have given you a good validation case as well, which you can go ahead and utilize in your reports as well. And if you want to compare, if you are dealing with some indoor environment studies and if you're having velocity or these kind of considerations in your setups, in your results, then obviously you can utilize this validation case. You can do as I have done and prove the authenticity of the numerical scheme, and with the finalized numerical scheme you can consider the same numerical scheme and you can extend the work depending on your research. All right, so I believe you have understood. And if you're like, you know, for example, as I'm mentioning that you can extend the research depending on your findings, what I meant to say is, like, you know, in this case we are just replicating a simple experimental study, but in your innovative, if you're trying to work on something innovative, then you might be having some other inputs in the design. You know, maybe you're adding some, you know, comparisons of flow field with the help of, with the presence of occupants or something else, right? So moreover, I mean, end of the day, firstly you have to show your validation for the numerical scheme. So this can be utilized, this case can be utilized, and with the same scheme you can extend the work by adding occupants, furniture, or whatever you want to do it. Clear? That is up to you. My intention was to explain you the strategy which I have done, and I've also compared the experimental and numerical setup with the help of these charts. I will just save them and I'll attach them in the resources. If you're having Origin software, if you want to just explore out, you can do it. And Origin is an interesting software. You know, you can see how neatly fashioned charts we have created, and there are numerous options in this. You can create vivid and different charts. Like you can see, for example, if I'm just example, where is the data? Yeah, if I'm selecting this and going to plot, you can see the different templates which are available and which I constantly use for my simulations results. So let us just catch up in the next video with some other work.